Okay. This is lesson 3, chapter 7. Excuse me. Um, the lesson is called Similarity and Transformation. So, just to remind something before this lesson, when we have transformation, we have transformations about congruency and similarity. Okay. Now, the transformations for congruency, meaning once I do the transformation, the shape stays the same, and the size stays the same. Now, which transformations deal with congruency? Those will be rotation, reflection, and translation. Okay? With these three transformations, the shape stays the same, the size stays the same. That is why we are saying they are the only ones we deal with when it comes to congruency. Now, in similarity, the shape is the same, but the size is different. And different how? It is either enlarged or reduced. Okay? Now, when it comes to this similarity, the transformation we will always think about is dilation. Because it's only during dilation a shape is enlarged or reduced. Now, for you to have a dilation, you need a scale factor. And the scale factor, you should remember the formula for finding it. Scale factor equals to image divide pre-image. Sometimes they call the pre-image the original shape. Okay? So up to there, we are together. Now, again, I have said similar figures, you have to be the same shape, but different sizes. So, triangle A is similar to triangle B because they are both triangles. They look the same, but they are different sizes. Okay? We move on. Okay. So now let's read here. Two figures are similar if the second can be obtained from the first by a sequence of transformations and dilations. So, you can do a rotation and a dilation. You can do a translation and a dilation. For you to be similar, dilation has to be there. This one doesn't matter. It can be translation, it can be reflection, it can be rotation. But as long as the shapes are not the same size, then we call you similar. Okay? Now, let us look at example A and example B. So we are trying to determine if triangle STU is similar to triangle PQR. Okay? So you're going to use the sides. You're going to use corresponding sides. So this is example A, page 537. All right. So we're going to say ST is corresponding to PQ. Corresponding, not congruent. I should just say corresponding. Don't use this sign, but you know what I mean. So side ST corresponds to PQ. ST, PQ. And then TU, QR. And then US, RP. Okay? So this is your pre-image and this is your image. Okay? Now you want to find the scale factor, and we said scale factor equals to image over pre-image. Okay? Which equals to PQ over ST, which equals to QR over TU, which equals to RP over US. All right. So I need to know what is the length from P to Q. I count the units. 1, 2, 3, 4, 5, 6. I write it over here. 6. I find for ST 1, 2, 3. I write it over there. 3. I do the same for QR. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go to TU. 1, 2, 3, 4, 5. This is a diagonal line. Since this is not a graph, I have to do Pythagorean theorem. Okay? To find PR. So this is PQ is how much? 6. And this is 10. PQR. Put 90 degree here. This is B. This is A. This is C. C squared equals to A squared plus B squared. 6 squared plus 10 squared. 36 plus 100. 136. C squared equals to 136. Square root of both sides. C equals to the square root of 136. I can leave it like that. Then I need to do the small triangle. And I should have drawn it the way it was drawn. ST. T, Q. S is 3, QT is 5. So we need to find this. So this is A, this is B, we need to find C. So C equals the square root of A squared plus B squared. 3 squared plus 5 squared. 9 plus 25. That should give me 34. So square root of 34. Okay? So square root of 136 over square root of 34. Alright. This should give me 2. This should give me 2. Now let's see if this one is going to give us 2. You see? Square root of 136 divides square root of 34 gives me 2. Now, the scale factor is the same to the corresponding sides. Then, these two triangles are similar. So we will write our sentence. Triangle STU is similar. That is the symbol for similar. Oh, yes. So then that's what we put over here. Instead of putting congruency, put similar. There, like that. Okay? So this is the symbol for similar. Triangle STU is similar to triangle PQR because the scale factor of the corresponding sides is the same. Okay? So first you have to do for all sides. And you have to remember we did Pythagorean theorem. So when you have a right triangle, if you don't know the diagonal distance, remember the Pythagorean theorem formula, apply, and do what you need to do. Okay? Now let's do example B. Okay? So example B, my pre-image and my image. So I'm going to do there. All right. So AB goes with EF. AB, EF. I will write like that. Okay? And since they're sides, I'll put a line here. And then BC with FG. Okay? BC with FG. Then CD with GH. Okay? And then DA with HE. I'm only going to do 3 sides. I'm going to avoid the diagonal side. I'm going to check these 3 sides. Okay? Alright, so let's see. Our next step, this is our first shape. So pre-image, this is our image. So we're going to find the scale factor. Scale factor equals to image over pre-image. Okay? EF, AB, FG, BC, GH, CD, and then HE over DA. Now let's put our numbers. EF, 3 units, no, 2 units. EF is 2 units. FG is diagonal, I'm going to avoid it. GH, 1, 2, 3, 4 units. HE, 1, 2, 3, 4. 4 units. Okay? Then AB, 1, 2, 3. 3 units. I'm not doing BC because it's diagonal. 1, 2, 3, 4, 5. So DC or CD is 5. DA, 1, 2, 3, 4, 5. All right. So we can change them to decimals to see if we have the same number. 2 divide 3, 0.666. 4 divide 5, that should be 0.8. And this should be 0.8. So they are not the same, so I will cross out my equal sign. Since they are not the same scale factor, I will say quadrilateral E or ABCD. Quadrilateral ABCD is not similar to quadrilateral EFGH because the scale factor of the corresponding sides is not equal, is not the same. Okay, because 66 hundredths is not the same as 8 tenths. So this is part 1. We have part 2 coming.